Okay, so let's take a look at number 1. Um, we've got a table. It says that the table above contains function values along the graph of a quintic polynomial function h of x. So we know that this is a 5th degree polynomial. It also says that the only zeros of h of x are zeros specifically listed in the table. So let's focus on those specific zeros. All right, so I'm only finding 2. It says, which of the statements that follow is or are true about h of x? Well, let's take a look at number 1. It says x plus 3 is a factor of h of x twice. So we know that x equals -3, so the factor is x plus 3. Let's take a look at the y values. Well, I've got a negative y value on the left, and I've got a negative y value on the right. So let's just take a look at what that would look like. This is our thinking process. Well, if you have a multiplicity of 2, that's going to have that bounce, right? It's going to be tangent to the x-axis, which means the y is positive on both sides of that, or the y is negative. So basically the y values are going to be the same sign if you have a multiplicity of 2. So if I take a look at that, I would agree that that is correct because we've got negatives on both sides. So that would imply that there is some sort of bounce going on. Now let's take a look at number 2. It says the multiplicity of x equals 1. So we know that this is a multiplicity of 2. It says cannot be determined, but it must be a 1 or 3. Well, if we take a look at that, to the left and to the right, we know that it's cutting through. We know that the y value is negative on this side. It cuts through, and then it's positive on this side. And that would indicate mostly a multiplicity of 1 or 3. However, it can't be 1 because remember that we have a quintic and these are the only zeros. So if this one has a multiplicity of 2, this one must have a multiplicity of 3 because they have to add to 5. So that means number 2 is not right. All right, so that means I can cross off the ideas that have 2 in them. Now let's take a look at number 3. If A is a leading coefficient, okay, remember that a leading coefficient determines the end behavior. So if A is the leading coefficient of the equation, then the A is negative. A is less than 0. So that means I'm going to look at the right side of the graph. Well, that's positive, which would tell me that my A is positive. And so that means this is false also. So 3 and 3. So that means my only answer is going to be A. All right, so let's take a look at number 2. It says find the value of k so that x plus 3 is a factor. All right, so in order for that to be a factor, I know my remainder must be 0. So there's a couple of ways to do this. I showed in the polynomial unit that we could utilize synthetic division, and we've practiced that. So this would be a 3, this would be a -2, this would be at k, and this would be a -3. And then remember though, when you're doing this process, you've got to add down 33 plus k times -3 is going to be -99 minus 3k. And when you add these together, which I'm going to do right now, so I've got -3k minus 102. Remember that if it's a factor, this remainder needs to equal 0. All right, so if I take a look at that, -3k minus 102 needs to equal 0. -3k is equal to positive 102. Divide by -3, divide by -3. I'm going to get k is equal to a negative. And then let me look at my answer. Okay, they're looking for the values. 3 goes into 10 3 times with 1 left over, so that would give me negative 34. So in this case, D would be the answer for that. And then 3, what can be said about the value of P of 1 and the remainder when P of X is divided by X minus 1? Well, if you were to evaluate P of 1, and if you were to synthetically divide by 1, because if that's the factor, X minus 1, the 0 is 1, the number that you get when you evaluate is going to equal the remainder of this polynomial. So P of 1 is going to be equal to the remainder. You could do that, but the whole point of the remainder theorem is that entire idea that if you were to evaluate, it is the same result as if you were to synthetically divide and you get the same remainder. Let's take a look at 4. It says, how many times is x minus 1 a factor of this function? Well, in order for me to do that, I'm going to go ahead and divide. And so I'm going to use synthetic division. So I've got 1, negative 3, 5, and negative 2. Get this out of the way. And then I'm going to divide by 1, right? X equals 1. And so here I'm just performing my synthetic division, but this is where some people go wrong. First of all, we guarantee that we did our right work because we got a 0 for the remainder. But take a look at this. If this was x to the 4th, then that means this is x cubed, and then this is x squared, and that this is x. So basically, my new equation is 1x cubed plus 0x squared minus 3x plus 2. Well, I need to synthetically divide by 1 again. I already know it's a factor once because I got a remainder of 0, but now I need to do it again. And now I need to check to see if I get another 0 here. So I get negative 2. Look at that. I got another 0. So this is now x squared plus x minus 2. So that's my new equation. It's already happened again. So now I know it's at least twice because I got a remainder of 0, but I need to do it again. So let's just see up until how many times it takes me. So this is 2 and this is 2. Oh, look at that. I got a 0 again. So that's 3 times. All right. So this becomes x, and that's just, so 1x plus 2. Let me just divide it again just to make sure, just so you can see what it's going to look like. And so right here, this is my remainder of 3, so that is not a factor. So this happened to have a multiplicity of 3. So the correct answer is D. All right, number 5, it says, which of the following binomials are factors of the polynomial function f of x? Well, there's a couple of ways to do that. We could do synthetic division. And so, or you can evaluate. So either you could go f of 1, which means x is 1, x is negative 1, or x is 3. So you could either evaluate. Sometimes if you evaluate, you taking the chance that you might mess up on the order of operations, but it's absolutely up to you. So you could do it this method, or you can synthetically divide. So let's do x minus 2, not x, but 1 minus 2 minus 11 plus 12, making sure that that's in standard form, which it is. So let's just go ahead and do this really quickly. I know that this is 1. I'm going to get a 1 here, negative 1, negative 1, negative 12, negative 12, 0. So I know that this is a factor because I got a remainder of 0. Now I'm going to try negative 1. So I'm just going to erase my work right here. So I've got negative 1, I got negative 3. I've got 3, I've got negative 8, And then I've got 8, and so that's not going to work. And then now let's go ahead and take a look at what if I were to do 3. And so I'm going to get 3, I'm going to get positive 1, a 3, a negative 8, a negative 24, and that's not going to help me out here. So it looks like I only have a for 5. Number 6, if f of x and x minus 1 is a factor, what would the function be? What would the function be written in completely factored form? Okay, so the cool thing about this is we can synthetically divide, right? So let me make some room over here. We already know that when we synthetically divide by 1, our remainder is going to be a 0. So I'm going to get here, I'm just going to make sure that I'm doing my work correctly, which I am because I got 0, so that's good. So we know completely factored form is x minus 1 because that gave us a 0. But remember now, if I started with cubed, that means this is going to be an x squared and then an x. So I've got 1x squared minus 2x minus 15. So one of two things can happen. I can go ahead and factor this. I can utilize my answer choices to maybe figure it out. But I already know that the two numbers that multiply to negative 15 and add to negative 2 are x minus 5 and x plus 3. But you could totally factor by grouping, but the bottom line is you're going to get x minus 5 and x plus 3. So I'm looking for the answer that has x minus 1, x minus 5, and x plus 3. So that looks like D is going to be our answer here. Let's take a look at 7. The graph to the right is a polynomial function with a relative maximum at the point negative 1, 4, and relative minimums at the points negative 4, 0, and 2, negative 2. Which of the following statements is or are true? The graph changes concavity at x equals negative 4. That is not true, simply because a graph is going to change concavity if it's at the inflection point. Okay, inflection point is based off of one of 3 conditions. One is that it's got a multiplicity of 3. The other one is it's the midpoint between the 0 and a max or min. And then the other one is the midpoint between max and mins. All right, so you can go back to your notes. It talks about the three conditions on which an inflection point occurs. So it doesn't change concavity at negative 4. What that does is it's tangent. So automatically number 1 is out. So we can eliminate those 3 answer choices. All right, so let's take a look at 2. The graph has an absolute minimum at point 2, negative 2. Well, that's absolutely the lowest point on the graph. So that is an absolute minimum y value. So 2 is good, which means 3 only isn't going to work. So my answer choice for 7 is A. But let's go ahead and take a look at 3. It says if C is the constant term in the equation, then C is a value between 2 and 3. Well, what do you know about the C value? Well, the C value is the constant, which is the y-intercept. So if I take a look at the y-intercept is between 2 and 3. So that is a true statement. So that's, again, another way to validate that A is our proper choice.